Hello everyone, Asari Deshmukh here. The topic for this video is instruction pipeline implementation and advantages of instruction pipeline. This video is created by Group 11, Division D, whose members are Anand Deshmukh, Asari Deshmukh, Anurag Deshmukh, Anish Deshmukh, Akansha Deshmukh, Amok Deshmukh. Basically, a group of Deshmukhs. So, what is an instruction pipeline? Instruction pipeline is a technique used in computer architecture to improve performance of processors. It involves breaking down the execution of instructions into multiple stages, with each stage being executed in parallel. This allows the processor to execute multiple instructions simultaneously, thereby increasing throughput and reducing the overall execution time. In an instruction pipeline, each stage of the instruction execution process is separated and performed independently, allowing for multiple instructions to be processed at the same time. This enables the processor to execute instructions faster and more efficiently as it can begin executing the next instruction before the previous one has finished.
So you may wonder what are these different stages and how are they implemented in an instruction pipeline. The first stage is instruction fetch. In this stage, the processor fetches the next instruction from memory. The second stage is instruction decode. In this stage, the processor decodes the instruction to determine what operation needs to be performed. The third stage is operand fetch. In this stage, the processor fetches any required operands for the operation. The fourth stage is execution. The processor performs the actual operation specified by the instruction in the stage. Last stage is write back. In this stage, the processor writes the result of the operation back to the appropriate register or memory location.
Well, okay, sounds cool. But how does it actually work? To get an idea of this, let us have a look at the flowchart presented on the screen. So, as we've discussed earlier, the first segment or the first stage of the pipeline is the instruction fetch stage, where the processor fetches the instruction from memory and stores it in an instruction register. After this, the instruction which has been read will be decoded to understand the meaning of the instruction. This was stage 2. Here, we also calculate the effective address of the operand. Next, it is checked whether the instruction is a branch instruction or not. A branch instruction is a type of instruction that causes the program execution to jump to a different location in the program code based on a certain condition. This is also known as a conditional branch or a conditional jump. Okay, so let's go back where we were and assume that it is not a branch instruction for the first time. In this case, an operand will be fetched from memory and the instruction will be executed. This would make up stages 3 and 4 respectively. Next, it will be checked whether there is an interrupt pending or not. If there is one, then it will be processed. Otherwise, the next instruction will be fetched and the cycle will continue. If it is a branch instruction, then there will be a pipeline stall. A pipeline stall is a delay in the execution of instructions in a pipeline processor caused by a condition that prevents the next instruction from proceeding to the next stage of the pipeline. After the pipeline stall, the program counter will be updated with the next instruction, and the pipeline will be emptied for the execution of the next instruction. In the case of encountering an interrupt as well, the interrupt handling routine will be followed, the PC will be updated, and the pipeline will be emptied. This is how a 4-stage CPU instruction pipeline works.
Here is an example to further understand the topic better. You can see that we have clock cycles or stages placed horizontally, and there are a total of 13 clock cycles. Similarly, we have instruction branches placed vertically, and as you can see, we have 7 of those in the table. Here, the instruction is fetched on first clock cycle in segment 1. Now it is decoded in next clock cycle. Then operands are fetched and finally the instruction is executed. We can see that here the fetch and decode phase overlap due to pipelining. By the time the first instruction is being decoded, next instruction is fetched by the pipeline. Now, here's something interesting. In case of the third instruction, we see that it is branched instruction. Here, when it is being decoded, fourth instruction is fetched simultaneously. But as it is a branched instruction, it may point to some other instruction when it is decoded. Thus, fourth instruction is kept on hold until the branched instruction is executed. When it gets executed, then the fourth instruction is copied back and the other phases continue as usual.
Advantages of instruction pipeline. First, increased throughput. The pipeline allows for multiple instructions to be executed simultaneously. This increases the number of instructions that can be processed per unit of time, thus increasing the overall throughput of the system. Second, reduced latency. The pipeline reduces the latency between the fetch and execute phases of instruction processing, as the next instruction can be fetched while the current instruction is being executed. This reduces the overall time it takes to execute the instructions. Third, efficient use of resources. The pipeline allows for better utilization of processor resources by overlapping the processing of different instructions. This means that the processor can perform more work in the same amount of time. Fourth, improved performance. The pipeline improves the performance of the system by allowing for more instructions to be processed in a shorter amount of time. This can be particularly beneficial in high performance computing applications such as gaming, video editing, and scientific computing. Fifth, simplified design. The pipeline simplifies the processor design by breaking down the instruction execution process into smaller, simpler stages. This allows for easier implementation and debugging of the processor. Overall, the instruction pipeline is a powerful technique that can significantly improve the performance of a computer processor by increasing throughput, reducing latency, improving resource utilization, and simplifying the design of the processor.
Here are a few disadvantages.
Instruction pipelining is a technique used in modern computer processors to increase their performance by allowing multiple instructions to be executed simultaneously. However, it also has several disadvantages. They include pipeline hazards. Instruction pipelining can lead to pipeline hazards, which occur when the pipeline is unable to maintain its normal operation due to dependencies or conflicts between instructions. There are three types of pipeline hazards: structural hazards, data hazards, and control hazards. These hazards can cause delays in the execution of instructions and reduce the overall performance of the processor. Increased complexity. Instruction pipelining requires more hardware resources, including additional registers, buffers, and control logic. This increases the complexity of the processor, making it more difficult to design, test, and manufacture. The increased complexity also makes the processor more prone to errors and bugs. Cost. The additional hardware resources required for instruction pipelining increase the cost of the processor. This can make the processor more expensive to produce and purchase, which may limit its adoption in certain markets. Energy consumption. Instruction pipelining can also lead to increased energy consumption as the additional hardware resources require more power to operate. This can be a significant disadvantage in mobile devices and other low power applications where energy efficiency is critical. Instruction ordering. Instruction pipelining requires that instructions to be executed in a specific order to maintain a pipeline integrity. This can limit the flexibility of the processor and make it more difficult to optimize for specific workloads or applications. Overall, while instruction pipelining can improve the performance of the computer processor, it also has several significant disadvantages that must be carefully considered in the design of modern computer architectures.